Hi guys! In this session, we will look at the intermolecular forces between molecules. Intermolecular forces are attractive forces between particles such as atoms, molecules or ions, and it exists when the molecules are sufficiently close to each other. There are two types of intermolecular forces, which are hydrogen bond and van der Waals forces. For van der Waals forces, it has two classes of forces, which are dipole-dipole forces and London forces. We will start with van der Waals forces first. Let's have a look on dipole-dipole forces. Dipole-dipole forces is an attractive force between polar molecules. Let's have a look on how dipole-dipole forces exist between HCl molecules. If we look at the diagram of HCl, there exists positive pole and negative pole in HCl molecule. When two molecules of HCl is close together, the positive pole of one molecule attracts the negative pole of another. So here exists the dipole-dipole forces. The more polar the molecule, the stronger the strength of its dipole-dipole forces. Thus, more energy is needed to overcome the forces between molecules. You got it? Okay guys, we have finished about dipole-dipole forces. Let's go to the next intermolecular forces, London forces. London forces, also called as dispersion forces. The dispersion forces are caused by the motion of electrons in a molecule or atom. The forces are weak but exist in any particles such as nonpolar, polar molecule, ion, and atom. Now, let's learn how the London forces may exist. Let's say we have two atoms of helium close together. As we know, helium atom is a nonpolar atom. I assign this as A and another helium as B. At any instant, it occurs an uneven distribution of electrons in atom A. So, there are more electrons in one side than the other side, which creates atom A as instantaneous dipole. The instantaneous dipole on atom A induces the neighboring atom B when they are very close. As neighboring atoms attract one another, the instantaneous dipole A induce the next nonpolar atom D, and D now become an induced dipole. The London forces is significant when atoms or molecules are very close to each other. Attraction between instantaneous dipole and induced dipole forms London forces. Alright guys, the last part to be discussed in this topic is about strength of London force, which is influenced by polarizability or size and molecular shape. Molecules with bigger size or larger molar mass will have more number of electrons, so polarizability of molecule increases and makes stronger London forces. We can see the trend in boiling point here is increased because polarizability increased. The factor of molecular shape is applicable for non-polar substance with the same molar mass. Molecules having larger surface area, it will increase the contact between molecules. Thus, there exist stronger London forces between molecules. Butane and 2-methylpropane are non-polar molecules and have same molecular size. The surface area of butane is larger than 2-methylpropane. Thus, it can form more London forces between molecules. The London forces between butane molecules is stronger. More energy required to overcome the stronger forces. Thus, butane has a higher boiling point. Generally, the dipole-dipole forces is stronger than London forces. But when the molar mass or molecular size of a non-polar molecule is larger than the polar molecule, London forces will be stronger than the dipole-dipole forces. For example, between CHF3 and CCl4, the boiling point of CCl4 is higher than CHF3. CHF3 has dipole-dipole forces and London forces, while CCl4 has only London forces. But the molar mass of CCl4 is larger than CHF3. Make the London forces between CCl4 molecules is stronger than van der Waals forces between CHF3 molecules. Now, let's discuss about another types of intermolecular forces, which is hydrogen bond. Hydrogen bond is an intermolecular forces between molecules that have partially positive hydrogen atom bonded to highly electronegative atoms, which are nitrogen, oxygen, or fluorine, and partially negative lone pair electron on nitrogen, oxygen, fluorine of another molecule. Ammonia and H3 is an example of molecule that can form hydrogen bond. Let's look at hydrogen bonding in ammonia when it close to another ammonia molecules. This hydrogen, which is bonded to highly electronegative N, meet another nitrogen on other molecule of ammonia will form hydrogen bond. Same as hydrogen bonds between acetic acid molecules. The hydrogen that bonded to oxygen meets with oxygen of another acetic acid molecule made up hydrogen bonding. Same goes to hydrogen bonding in methanol, which is formed when hydrogen atom bonded to oxygen meets oxygen of another methanol molecule. Okay guys, we almost finished discussing about the hydrogen bond. Let's see how the strength of hydrogen bond is measured. There are two factors which influence the strength of hydrogen bond. The first one is the electronegativity of elements. Because the hydrogen bond involves molecules that have F, O, and N, and we know that the electronegativity of F is higher than O, and electronegativity of O is higher than N, so we can predict that higher electronegativity stronger the hydrogen bond. This explains why hydrogen bonding between water molecules, H2O, is stronger than hydrogen bonding between ammonia molecules and H3 because oxygen is more electronegative than nitrogen. Another factor that influences the strength of hydrogen bond is the number of hydrogen bonds present between molecules. More hydrogen bonds present between molecules, stronger the hydrogen bond. This factor can be used to compare the boiling point between HF and H2O. Although F is more electronegative than O, the boiling point of HF is lower than H2O because of H2O can form more hydrogen bonds between its molecules than HF. We already understand about the intermolecular forces that can exist between molecules. After all, we can apply the knowledge about the intermolecular forces to predict the boiling points and the vapor pressure of our molecules as they relate one another. Okay guys, that's all for this session. Hope you enjoyed this lesson. Bye!